Okay, here we are, 7.1, question number 1. So 7x squared minus 2 equals 0. All right, so this section is about solving x squared equations, really, and that's what chapter 7, we're in chapter 7, it's all about handling x squared equations. And I know we've done this before, we've done a fair bit of this. Let me give you the instructions as a reminder. When you have x squared with no x to the first power, like this one, see how you just have x squared in numbers? Versus, sometimes you have 7x squared minus 3x minus 2 equals 0. That's different. So if you just have x squared and no x to the first power, like we do here, get x squared alone, and then you put root and plus or minus root, and you're done. It's really quick. Whereas if you have, let me give the other instructions, if you have x squared and x to the first, that's where you do the get a 0 thing, you know all that, right? Get a 0, factor, with the parentheses, that whole thing. So I want to make sure those two strategies are clear in your mind. There's two different ways we go. There's going to be more, but for now, there's two different ways we go for x squared. If you just have x squared and no x to the first, like we do here, right? There's just x squared, and I don't have x to the first anywhere. Those are easier. Just get the x squared alone and put the root on it, and you're done. And we've done a lot of these where we have x squared and regular x, but you get a 0 and factor, right? Remember those? Okay, so I'm just going to get this x squared alone. Just jump this 2 over. Negative 2 over becomes a positive 2. Good so far. And just divide by that 7. So x squared is 2 sevenths. We get to there. So I'm just getting the x squared alone. X squared's alone. Now what do I do? Do the root on it. So root, and what are you supposed to do? You put a root and a plus or minus root. Don't forget the plus or minus. Very easy to forget that. I always say the goofy saying, when you put a roof on the house, you got to go up and down the ladder. Try to help you remember up and down, plus and minus. It's a little goofy, but hopefully it'll help you remember. When you put a root on both sides, you've got to go up and down the ladder. Roof on your house, plus or minus. All right, so what do you get? Plus or minus root of 2 sevenths. But we can't leave, in fact, we can't leave the answer that way, can we? Because that means that root over the whole fraction means a root top and bottom. We never leave roots on the bottom. So multiply top and bottom by root 7 to get the final cleanup. That's root 14 over plane 7. And we're done. Is that good?
Root 14 over plane 7.
Do you see why it's plane 7 on the bottom? Because 7 times 7 is 49. The square root of 49 is 7. On the top, it's just root 14. Can't square root 14, but you can square root 49, huh? Is that okay? That's the answer. There's two answers. It's plus and minus. Let's go type that in. Yeah, notice how the root's not in the denominator any longer, is it? It's just in the numerator, right? Why did it go away in the bottom? Because we did 2 of them. 2 root 7s made 1 plane 7. So plus or minus calculator. So it not only wants this, but it also wants you to hit the buttons on your calculator. So take square root of 14, divide by 7. Let me see what you should get. It should be about a half, plus or minus 0.5, 0.6, something like that. What do you get?
0.534.
How many places it want? 3 decimal places. So 0.534, what comes next? 5?
Yeah, 5.
So then this third place must round up. Plus or minus 0.535. Does that make sense? They said 3 places up there. So you circle the third place, look 1 to the right, 5 or more, go up. Plus or minus 0.535. They want the calculator also on that. Yeah?
They want the positive and negative of it.
Yep. Right there. Plus and minus. Yep.
I don't think they'll take that from I didn't do that.
Okay, so x plus 4 squared. Okay, so same thing. You've got a big 2-power piece. No, don't foil out that left side. Don't do this. Don't write 2 of these, although that's not illegal or anything. It's not the easy way to go. We don't want to mess with any of that. Don't do that. Instead, what do you do to get rid of that 2? Throw the root on right now. Put the roof on the house right now. Both sides. Yeah, and it's got to do, and remember, you get plus or minus on the right side. Plus or minus when you do that.
On both sides?
Plus or minus on the number side. Yeah, so yes, you just put plus or minus on the one side. So roof on the house, up and down the ladder. Good like that? So you get in the theme of how roots and 2 powers work? They undo each other. They're opposites. They're like a poison and the antidote.
It's like plus and minus.
So it gets rid of it, right? So when you got a 2 power, you put a root. When you got a root, you do a 2 power. They just undo each other, don't they? So the root cancels the square, and you get x plus 4 is plus minus. The root of 64 is just 8. Now, we need one more step. How do we get x alone? Minus 4. And those are actually 2 separate answers. You compute them one at a time. What do I mean? I mean it's plus 8 minus 4, and it's minus 8 minus 4. Which is, right, everybody see what I did? I just did the 2 options on the 8, plus 8 minus 4, and minus 8 minus 4. The 2 options on the 8. And what is that? What is 8 minus 4?
4.
And what is minus 8 minus 4?
Minus.
There's our 2 answers. Is that good? Here, are those really the answers?
I don't know, check.
You don't have to check, not required, but I just wanted to show you that it's really true what we're doing here. If you went back to the beginning and you put in 4 for x, 4 plus 4 would be 8, 8 squared, yeah, clearly that's 64. That one's obvious. But how about the negative 12? Is negative 12 right? What would be negative 12 plus 4? Negative 8. Squared? Yeah, sure enough. That's exactly right. Those are the 2 answers that make it true, aren't they? All right, let's keep. Okay, so x minus 9 squared is 45. So same thing. Put the roof on the house. Up and down the ladder. Get that 2 out of there. So don't write 2 of them in FOIL. Just get rid of that 2. Just put the roof on the house. Get rid of that 2 from both sides. Roof on the house, up and down the ladder. Good. Rooting cancels squaring. And 45. Break down the 45, that's 5 times 9. 2 3s, so 2 3s in, 1 3 out. We good there so far? And then x, what's the last step to get x alone? Just add that 9 over. Or I'm just going to jump it over. Just grab that minus 9, and now when you jump it over, it becomes a plus 9, and it lands right there. I mean, you can put it in the front or the back, but we're done there. Do you realize it can't add to that 3, and so it's not going to become 9 plus 3 is 12, and 9 minus 3 is 6. No, because they're unlike terms, aren't they? They can't add or subtract. They're unlike. Remember, you can't add a plain number with something that has a root. They're unlike terms. It just stops right there. If this 9 had a root 5 on it, then yeah, you could add 9 root 5 and 3 root 5. That'd be 12 root 5, right? They have to have the same roots to be able to add them. Otherwise, they're unlike, and we just stop right there. Is that good? So that's exactly what they want. They probably want... okay. X minus 6 squared is minus 81. Can you do that? Same thing, put the roof on the house, up and down the ladder. Same thing.
said item.
Right? Exactly. So roof on the house, roof over the left side, over the right side, and plus or minus. Everybody good to that? That's going to be 9i over there, isn't it? Everybody's plus or minus 9i on the right side. Is everybody seeing that? Because that negative is in the root. When I put the root over the left side and over the right side, I end up with a negative in a root, but you know quite well what to do with that now. The negative pops out as an I, root 81, and root 81, you know, is just 9. So it's I times 9, or 9i, however you want to write that. The rooting cancels the squaring there. Oops, I keep missing it. Good to there. Everybody good with that 9i over there? And then we grab the 6 and jump it over. Becomes a plus 6. I'm going to make it 9i, and that's it. We don't have to do that one on a calculator because it ain't real. There's nothing you can type in for I. We're just done right there. They won't ask you for a calculator answer. We can't add those together, right? We can't add them to get 15 because they're unlike terms, aren't they? Getting all those mini algebra rules down. There's a lot of them. All right, I'll move on. Let's take a look. Oops. Oh, yeah, that's it. All right, so there it is. So x minus 3/11 squared is 2/11. So you know what to do first. Put the roof on the house. On the house. Up and down the ladder. Good.
So, okay.
Like that.
What that's saying is root of 2 over root of 11, right?
Yeah, the root's over the whole fraction. Yeah, good. Good. So this right side is a root 2 over a root 11. This side, the root cancels the square. You're good to there?
Do we have to get rid of the
Now,
11s?
root 11 on the bottom. We don't leave roots on the bottom, do we? So, we multiply top and bottom by root 11. We all good? And then jump this minus 3/11 to the other side. Becomes, whoops, positive, regular, normal 3/11 plus or minus root 22 over plane 11. We're done. Everybody okay with that? Right? 2 times 11 is 22 on the top there. Bottom, root 11, plane 11. Is that okay? All right. All stresses and never, huh? All right. So x squared plus 6x plus 9 is 81. Okay, so we're going to solve this with a little trick. What I'm going to do is I'm going to say, hey, that left side, x squared plus 6x plus 9, I can write that left side as a couple of parentheses, like I can FOIL it. So what is it? It's x what? Yeah, plus 3, huh? Just factored it, huh? Now you might wonder why in the world I'm factoring, but that's a good question, but just hang with me for a minute. Everybody good to that point?
We can root it.
So x plus 3, and so that's x plus 3 squared, isn't it? Pretty good to there? It's the same thing twice. Whenever you have the exact same thing twice, identical twins, you just make it squared. Okay, great. So what's so great about that? Well, because now I can do what we did in the last few problems. I can put the roof on it, up and down the ladder, and the rooting will just cancel away the square, huh? Everybody see that little trick?
Plus or minus 6.
So x plus 3 equals plus or minus 9. Good to there. Everybody good? Bring it up here. Okay, now, last step, grab that plus 3, jump it to the other side, and it becomes minus 3, plus or minus 9, right? The positive 3 jumps to the other side, becomes a minus 3. Plus or minus 9. What are those two answers? Minus 3 plus 9, and minus 3 minus 9, which is 6 and negative 12. Those are my two answers. Everybody tracking with me? 6 and negative 12. And there we go. So do you see that trick? Because we're going to push the trick even harder here in just a couple of minutes. So you want to get this first level. We're going to build from here. Everybody see what we did? The left side factored as the same thing twice. And that means it's squared, and that means you can root it. Really nice things happen when it factors as the same thing twice. In a minute, they're going to give me a mess that will not factor as the same thing twice. And I'm going to purposely give it just what it needs to make it factor as the same thing twice, because I really like what happened here. Whereas you get the 2 power, you can just root it, plus or minus, done. It's really nice when you can get it to factor as the same thing twice. So keep that in your mind. That's really nice when you can get it to factor as the same thing twice. So in a minute, what they're going to do is they're not going to give me that 9. They're going to go, how are you going to solve that? And I'm going to go, oh, I'm going to give it just what it needs, and what it needs is a plus 9. So it'll factor as the same thing twice, so it's a 2 power, so I can get rid of the 2 power with the root, and I can finish the problem. I'm going to give it what it needs. That's called completing the square. Making it be the same thing twice, be squared. I'm going to complete it. I'm going to give it what it needs in a minute to make it do this. Does that make sense? So take this in. Was there a question?
Yeah, it's when you're done with this question. I can...
Just to see it happen. So then we go deeper, you're okay. So let's see, y squared minus 2y plus 1 is 30. So go ahead, factor that left side. That left side is going to be 2 parentheses, same thing twice. Identical twins on that left side. So factor those identical twins. Everybody get that? Y minus 1, y minus 1. Identical twins. It's really nice. So if that positive 1 wasn't there, I'd put it there to make this happen, because this is so nice. Y minus 1 squared equals 36. We good to there. Right, identical twins, just make it squared. And then roof on the house, up and down the ladder. Rooting cancels squaring. Y minus 1 is plus or minus 6. Root of 36 is 6. Good to there. See how the left side, the root, eliminated the 2 power because they're opposites? And then take that minus 1 and jump it to the other side. Positive 1. Right? Positive 1 plus or minus 6. So positive 1 plus 6. Positive 1 minus 6. Oh, no, where'd that root come from? What am I doing? So 7 and negative 5. Good? Making sense? Any questions I can answer? Yeah.
I'm sorry to ask this. Can you go back to number 7 for a second?
Sure. Is everybody good with this one? That all good? So we're always factoring the left side as identical twins. That's really nice, because you get the 2 power, you just get rid of it with a root. So that's super nice. Number 7?
Yeah, so it asks for, like, decimal answers later.
Yeah.
And I did it right. Like, I checked even online with, like a calculator that would let me enter, like, parentheses and all that.
Yeah, okay, yeah, let's do it. That's a
It's
good
not
question.
Working,
So
so.
3/11 plus root 22 is, here, let me kind of get this out of the way. Yeah, good. You guys have your calculator? That's a good one to do. Let's do that. So 3/11 plus root 22 over 11, and the other one would be 3/11 minus root 22 over 11. Okay, so yeah, do you want to type this in your calculator? Answer should be about, let me see, 4, 5, it's almost 5, so it's just under half. And I don't know, it's like 0.8 or 0.9 or 0.7 or 0.8 or 0.9 over here, I don't know. Under 1.
0.699.
Oh, 6, okay, I'm a little over it, huh? So it's
You round it.
0.69991. And they said 3 places, so let's say 699. Okay, and other side should be, is it negative? I think it's maybe barely negative. Negative point, I don't know.
Negative 0.15.
154, rounded.
I figured it, I accidentally hit a decimal.
We good?
I had 2 decimals in my answer.
All right, good.
It's a dot I couldn't see. I thought it was like a dust on the screen.
All right.
Sorry about that.
No. Okay, so x squared plus 2x is 13. See how I'm leaving a gap there? Because I'm going to stick in the gap what it needs. See how we're going to solve this problem? How are we going to solve this problem? Now they're missing the third number. What do I mean? Let's go back. Let's compare. See how right here they have the third number there for me? So these factored beautifully as the same thing twice, identical twins. See how right here they have the third number? So they factored as identical twins. And that's super nice because then you get the 2 and you get rid of it with the root. That's what we want. We want to put that third number in there so that the 3 of them will factor as identical twins. Well, okay, but how do you know what that is? What number goes there so that it'll then factor as the same thing twice? How do you know what number goes there?
It has to add up to be 2.
Yeah, it's going to be 1 in this case. Here's the secret. You take what's in the middle. Whatever's in the middle, you put it over 2 and you square it. So it's the middle over 2 squared. So this is 1 squared. 1 times 1 is 1. That's the secret. So it's plus 1.
Is it always going to be over 2?
And whatever you add to one side, you have no choice but to add that same thing to the other. It's always over 2. It's always over 2. So does everybody see that little formula? So I'm giving you the special sauce there. I'm giving you the special formula that will always make you correctly find that third number. It's the middle number over 2 squared. Always. And when you add it, you got to add it to both sides, right? Because whenever you bring something new to the problem that wasn't already there, you're going to do it with balance, don't you? We have an equal sign, so that means left and right. Does that make sense? That plus 1 is brand spanking new. He wasn't there before. He wasn't part of the original question. It's something new I brought into the problem. So whenever you bring something new in, you got to do it with balance, right? Got to keep it balanced. If it was equal before, you treat them the same, they'll be equal after. Right? Now, guaranteed, these 3 will factor as identical twins. Other side is just 14. So how do the left ones factor? Plus 1 this time. See, it's identical twins. That makes plus 2x in the middle and plus 1. So then that's squared. And now that it's squared, it's a cake problem for us, right? It's easy now. Now you just put the roof on the house, up and down the ladder, rooting cancels squaring. X plus 1 is plus or minus root 14. Good? Am I going too quick? It's all the same old, right? And then just take the 1, jump it to the other side, becomes negative 1, plus or minus root 14, we are done. Everybody see how that worked? So when that third number is missing, You give it what it's missing. You got to do it to both sides. You give it what it's missing to make it complete the square. That good? Is that okay on that? And now, why does this little formula work? Middle number over 2 squared. Where'd that come from? Well, think with me for a second. Look back here at this one. If this 9 wasn't here, well, think about what factor. When I factored these three a couple problems ago, it was plus 3, wasn't it? Why? Because 3 and 3 multiply to be 9, and they add to be 6. Remember, you multiply to be the number at the back, you add to be the number in the middle. So if somebody just gave me the 6, which is what they're doing, they give you the middle, and they're asking you to find the third number, it's not there, right? That's what's happening in this problem. I've got the middle. Whoops, I just erased it. I've got the middle, and the third one wasn't there in the beginning, right? That's what we're doing. If somebody gave you the middle, and they didn't tell you the back number, you could find it, because that middle, you have to have 2 numbers down here in the factoring that add to be 6. If I said, hey, I got 2 numbers, and they're the same, and they add to be 6, how would you find what numbers I'm talking about? If 2 numbers are the same, right? These got to be identical, right? If I say I'm thinking of 2 numbers, they're the same, and they add to be 6. Well, it's got to be 3 and 3. It's got to be half, doesn't it? If 2 things add, and they're the same, and they make something, then they're half of that thing. Half of it, right? So that's where the half comes from. But then where's the squaring? Well, then what do you do with that 3 and 3? You multiply them. You square them. 3 times 3, don't you? That's why you always take what's in the middle. You have it, right? That's the 3. And then you square it. 3 times 3, 9. That's why that formula works. That's exactly what goes on when you FOIL. So that's the idea. Middle number over 2 squared. By the way, I want you to see that the answer we just got, we could not have solved it any other way that we know of so far. So what am I talking about? Let's go back to the original question. Up to now, what have we always done with x squared? Do you realize we just conquered a new mountain there? What am I talking about? If I said, solve that x squared, what have you learned to do with x squared so far? Get a 0, right? See monster, get a 0, that whole thing. See how that would not have worked? They were just giving us easier ones earlier. Now it's time for the real deal. If you would have moved that over, got a 0, and then tried to factor that thing, that doesn't factor. X squared plus 2x minus 13, you would be stuck in the mud and done. You would not be able to finish that problem. Do you realize this new little trick we're doing is enabling us to solve problems we could never have solved before? By finding that magic third number that makes it become 2 power, we can solve it when we could not have before. All right. So this one. All right. So x squared minus 4x is 10. By the way, let me try it the old way. You just watch me for a second. It won't work. Minus 4x minus 10 equals 0. You know, what multiplies to be 10? What times what's 10? Well, 2 and 5. That's about all you got. Do those add to be 4? No. No way, 2 and 5. Why do I do 1 and 10? Well, they ain't going to make 4 either. You see, it just doesn't factor. Real life things don't factor. They build bridges and do real life things with math. They don't factor. That's just gimmicky. That's just when they make the problems nice and easy as you're learning the field. But now you guys are moving into more advanced algebra, so things aren't always going to factor. So, do you realize the old way to get the 0 for the sea monster is not going to work? We need this new trickery. So go ahead, do the new trickery. Find out the magic third number. Complete him. Give him what he needs to factor as identical twins. Complete the square. Yeah.
Is it always plus the number that you found?
Yeah, because it's squared at the end.
Oh,
So it's always positive, isn't it? So take that negative 4, put it, remember what we always do? We always take the middle over 2 and then parentheses around it, 2 power. It's always what you do. That'll always give you just what you need to find that magic third number, which will complete it, right? Give it just what it needs. Right? So that magic third number over 2 squared. Magic third number like that.
Does it always ask for the 1,000?
Yeah, I think so. Yep. Okay, good. So that's what? Negative 2 squared, positive 4? Positive 4. Everybody get that?
It's going to be something negative.
It's always positive. The number we add is always because it's squared. So it's always positive. So that's the magic number. It's just what's needed to complete it. You have to add it to both sides.
X equals -2 minus square.
Is that good? Now the left side guaranteed will factor as identical twins.
Minus 2
Minus 2. Everybody see that? By the way, notice one more observation. The number in the parentheses right before you square, that will always be the number that ends up factored in the parentheses. You see that? Number in the parentheses ends up being the number in the parentheses. That'll always happen, which, like, who cares now? We can do that without even thinking. But in a minute, we're going to have ugly fractions, and that'll be nice to have a little help. So we won't have to think of it ourselves. We'll just go, hey, what's in the parentheses, in the parentheses. Boom. That'll always work. Is that good? And then you know the rest from here, right? Squared. What do you do with the 2 power? Put the roof on your house. But that takes you have to go up and down the ladder. Rooting cancels squaring. Plus or minus root 14. Like that. So just jump that minus 2 to the other side. It's positive 2. Plus, oh, I forgot the root. Root 14. 2 plus or minus root 14, we're done. Wasn't that almost the answer last time? I don't know. Whatever it was. It was 1. Okay. It's close. We had another root 14, didn't we? Is that good? Does that make sense? So you're giving it just what it needs to make it factor as identical twins. You're completing it. Remember the olden days when they used to say your husband or wife completes you?
In the old days.
I just don't ever hear that anymore. I don't know. My sweet little wife completes me. I mean, she's not perfect, but she's close to it. So, sorry, it's just how I feel. So anyway, but I never hear anybody talk that way.
Oh, no one's perfect.
They complete me. Let's try this. Okay, so we got x squared plus x, got the 1. So we got to find the magic number that'll complete it. That'll give it just what it needs to factor as identical twins. That's the game plan. Okay. Now what number's in the middle there?
1.
Yeah. 1. So, what's the plan? Middle over 2 parentheses squared, right? That's always how you find the magic number, that perfect amount to complete it. So 1 over 2 squared, which is, what's 1/2 squared? 1/4. Fraction time. No, they want fraction answers. Sorry. Not decimals. They want fraction answers. So add. Now I'll help you. I'll give you steps where you won't ever really have to, well, slightly have to mess with fractions. Good so far. Right, I added the magic number, the amount that will complete it perfectly. Okay. Now, this is x, and then what goes in the back here? If you don't want to think hard, number in the parenthesis.
1/2.
It's number in the parenthesis. Every time. Plus, plus. Why? Because those add to be 1, and they multiply to be a 4th, don't they? A half and a half add to be 1. And a half times a half multiplies to be a 4th, doesn't it? All right, good? Is that making sense there? So it's automatic. You don't have to think hard. Whatever number's in the parenthesis, that will be the number factored in the parentheses. In the parenthesis, in the parenthesis. Now, the other side, I am going to have to do a little fraction work. 1 and a 4th, I got to add them. How do you add a whole number and a fraction? Yeah, put this over 1, make it look like a fraction, and then multiply top and bottom to get common denominator. Top and bottom by 4. So that'll be 4 over 4 plus 1 over 4.
Or you can just go 1 times 4.
Yeah. 5/4. And then this is a, or use calculators, that's fine too. X plus a half squared. We get to there. And you know the drill from here. Roof on the house. Get rid of this 2 power. We're almost there. That wasn't too much fraction stuff, right? So roof on the house, up and down the ladder. Rooting cancels squaring. So what do we got? X plus a half, plus or minus. So the root of 5/4. What do we do when we have a root over the whole fraction? Root the top and root the bottom. Root of 4 on the bottom? Plane 2. This will always happen. Everybody see that? Let me mention that so it'll make things a little easier for you. So whenever you have the root over the whole fraction like that, the bottom number will always root clean. Every time. The bottom number will always be 4 or 9 or 16. Usually 4. Like 90% of the time it's just 4. Always. Guaranteed. It will never be an unrootable number. It'll always be a number that's rootable. So you'll always root the bottom and the root will leave the bottom. Right? Because when you do the root of 4, it's gone. It's not there anymore. The root's only on the top because you can't root 5. Right? That'll always happen. When you're completing the square. It'll always happen. Jump the half over. Becomes negative a half. Plus or minus root 5 over 2. We're done. There it is. Something we never could have solved by the sea monster method with the 0 factoring. Couldn't have done it. We need this trick. Yeah, Abraham.
Can you go for the 2, from 4 to 2, square root 4 to 2 to 2?
Yeah, so the square root of 4?
Yeah.
It's just 2? That's all I'm doing. Yeah, so the square root let me talk a little bit more about this. So the square root that's on the entire fraction, you try to root them both, right? Because a root on a whole fraction is root of both of them, but you can't root the 5, so it just stays there. But you can root the 4, so it vanishes. It does its root on the bottom and vanishes, just plain 2 down there. Is that good? You okay with those fractions? What made fractions happen this time?
No.
Odd number in the middle. Do you see that's the issue? Hold on 1 second. Everybody see that's the issue?
Yeah.
When you have an odd number in the middle, it doesn't divide by 2, so it stays a fraction. But if you have an even number in the middle, then you divide it by 2 and it's clean. So when they put an odd number in the middle, those are going to become ugly fractions. When they put an even number in the middle, those will be cleaner. Exam, no secrets with me. Exam we take 2 weeks from today. Practice exam next Wednesday. 1 even in the middle, 1 odd in the middle. 1 easy one, 1 hard one. On that. Question, Car?
Okay, so on the left side we have 5/4. Why on the right, skip over it, now you have 5 over 2.
Right, yeah, so that root that's over the whole fraction, you go ahead and put that root on both, because a root over a whole fraction means rooting both of them, right? And the square root of 4 is just?
2. Oh, okay.
Yeah, whereas the root 5, you can't root 5, so it just stays on the top. That's why the root stays on the top, because you can't root 5. But it goes away on the bottom because we rooted it. We were able to root it. And that'll always happen. You'll always be able to root the bottom and not the top.
Thank you.
We good?
So when you square, no, never mind. I got it.
We're
You have
good?
to get to the top, right?
What's that?
When you square root when you just get 2, don't you have to do to the top as well?
Yeah, I tried to, but you can't. Right? I said, hey, I got a root on the whole thing. So that means root the top, root the bottom. And the root 5 said, can't root me. So it just stays there. What you can root for. Right? That's what roots do. They try to root the thing. If they can't, they just stay there. If they can, they do it and leave. Right? Everybody seeing that? It's not going to be an easy one. So it's t squared. I'm going to make that x. Okay. So there we go. So odd number in the middle, it's going to be fractions. So find the magic number which will complete it. Bless you. So you guys finding it okay? So the middle number over 2 squared, 49/4. That's the magic number. Everybody seeing that? You got to add 49/4 to both sides.
Yeah, and then do it again. Combine on the second one, turn it into-
Is that okay? Everybody see that? Middle number over 2 squared, right? And now the left side is guaranteed to factor as the same thing twice. Guaranteed. Well, how do you know what it is? The number in the parentheses. See, now it's helpful. Whatever's in the parenthesis is in the parenthesis. Same sign, same everything. What's in the parenthesis? Negative 7/2. Negative 7/2. Negative 7/2. Guaranteed. You can see that they multiply to be positive. 2 negatives multiply to be positive. 7 times 7, 49. 2 times 2, 4. And they add. That might be a little harder for you to see. How do they add? What's 7 halves and 7 halves? 14 halves or 7. Negative. Right? It's true. It works. You good? How you doing? Okay, now the right side. What do you do on the right side? You got to add those together. So put the 7/1, and you got to multiply top and bottom by 4 for common denominator, huh? You got to make those denominators the same. So we get. This is well, funny. It looks like a 7 down there. It's all messed up. It's over 1. So multiply top and bottom by 4. Is that good? 28/4 plus 49/4. We good? Add these together. Is it 74/4? No, 77. 77/4. Huh? Having an adding problem. 77/4. We good? Is everybody? Am I losing you? See what's happening there? How we doing? Now, put the roof on the house, up and down the ladder. Problem's basically done. Roof in the house, up and down the ladder. Now notice, this root is on the entire fraction. It'll try to root the top. You can't root 77. It'll just stay up there. But you can root the 4 always. Remember, I guaranteed. When math says always, when I say always on behalf of math, I don't mean most of the time. I don't mean 99% of the time. I mean without fail, you can prove it. 100% of the time, it will always be a rootable number. So the square root of 4 is 2. So it is plain 2 down there. Like that? That good? Other side rooting cancels squaring. So we get x minus 7/2 is plus or minus root 77/2. Last step. Just jump that minus 7/2 to the other side. Becomes a positive 7/2. So the answer, I'm running out of room completely. Positive 7/2 plus or minus root 77/2. There it is. Abraham.
If there was, like, on the bottom of the square root, if it was an odd number, then you'd have to multiply top and bottom, right?
I'm sorry?
On the, 49 over 4, and then you square root it, right? So if it was if that 4 was an even number, then you.
Wait, hold on. 4 is an even number.
No, odd number, sorry.
If 4 was an odd number?
Yeah, then you would have to do, say it was 5, then you'd have to do 5.
Yeah, it never will be. That's what I'm saying. It'll always be a rootable number. It might be 9, it might be odd, but it'll be an odd rootable number.
Yeah, now I just click why you just go to 2.
Yeah. Because I just rooted the 4. Yeah, it'll always work that way. It'll usually be a 4. Almost all the time it's 4. Every now and then it'll be a 9.
Okay.
And it'll be 3. Yeah, but it'll always be a rootable number. We'll prove it probably tomorrow. Wednesday. So, root of 4, it'll always be a rootable number. You'll never have to do that on the completing the square roots.
But if you want to prove it tomorrow, I'll watch it.
So there it is. All right, we good? You hanging with the mess? It's a little...
Just gonna find a 0 on it.
All right, try that one. Yeah, I mean, you could try it the old sea monster way, but it won't work. You got to do the new trick. So you know what you should do with that 102 right away?
Jump it over.
It's just in the way. Just jump it over. It becomes minus 102. Like that, right? Just get it out of the way because it's not the magic number. It's not the one that will complete it. So just get it to the other side and find the magic number. Find the number that will complete it. I just subtracted 102 from both sides.
Yeah, but why?
Because I need to put right here the special number. The number that will complete it. The number that will make it factor perfectly. So that 102, they just left it sitting there. So I'm just like, hey, move that thing out of the way. That's not, and then I got to find it by taking the what? The middle over 2 and squaring it. So you got to find the special number that will be just what it needs to complete it. Hey, the one in the middle, is it even or odd? It's even, so this should be an easier one. No fractions. No fractions on this one. Right? Remember, when the middle's even, they're nicer. I'll give you one even middle, one odd middle. This is an easier one. So that'll be 15 squared, that's 225. See, no fractions. The magic number's 225. That's just what it needs to complete it. Good? So add 225 to both sides. That's the magic, that's the special number that will make the left side factor, guaranteed. That's the same thing twice. We're good? Now, if you're wondering, well, how does it factor? I hope you heard my rule. You don't need to guess. How does it factor? The number in the parentheses is the number in the parentheses. Same sign, same everything. What sign's on that 15? Nothing, which means plus. Plus 15. I mean, it's literally same. Same sign, same everything. The other side was at 123?
Yeah, 1 to 3.
Good? Yeah.
When I get to, I could just wait.
It's going to be root of 123. Negative 15 plus or minus root 123. All right, let's go on. So 2 of them is squared. And roof on the house, up and down the ladder, rooting cancels squaring. So we get x plus 15 is plus or minus root of 123. 123 is not rootable, just leave it that way. We're good to there. Last step, jump that 15 over, and it becomes negative 15 plus or minus the root 123. There's our answer. Are we good? So they're easier when there's even in the middle, you don't have fractions. Questions on that? No questions? All's well.
It's gonna be a plus and a minus, isn't it, since the middle's gonna be, no, it's not.
Okay, try that one. The middle is 1, so it's odd, so it's going to be fractions, right?
Can we move the two?
Yeah, just get that 2 out of the way. Yeah, that plus 2, he's just hanging out where he shouldn't hang out. Move him out of the way. Okay, create a blank, a space for the magic number. So find the magic number. So what's the magic number? 1/4. So you should be adding a 4th to both sides because it's a half squared. It's a 4th, right? Because what's in the middle right now is a 1, isn't it? So you put the middle number over 2 squared. That's 1/4. So 1/4 is what you add to both sides. Then the left side is guaranteed to factor as identical twins, same thing. Twice. So, now what's it going to be? The number in the parentheses is the number in the parentheses. Guaranteed. Same sign, same everything. What's in the parentheses? Positive 1/2. Positive 1/2. Positive 1/2. Good? Right, because 1/2 and 1/2 multiply to be a 4th and add to be 1, don't they? That's correct. Now, what about the other side? What do you do with -2 plus a 4th? Put it over 1. Yeah. Multiply top and bottom by 4 to get a common denominator. You get -8/4 plus 1/4, which is -7/4. So, we good so far? Everybody good so far on that? So on the right side, you got to get a common denominator. So I multiply top and bottom by 4, -8/4. That's just a fancy -2. That's -7/4. Good. So far, so good. Let me bring it over here. So we have x. Something kind of scribbly here. Try this again. X plus 1/2 squared is -7/4. Okay, now what do you do at this point? Square root it. Put a roof on the house, a root over the left side, a root over the right side, and plus or minus. Up and down the ladder and put a roof on the house, right? So rooting cancels squaring, so x plus 1/2 equals plus minus. Now what does a negative in a root do? Kicks out an I. So this negative, now where does the I go? Nowhere but right in front of the root. Don't let it go past the plus or minus or anywhere else. √7/2, right? Again, the bottom number is rootable, isn't it? √4 is just plain 2. But the root stays on the top because you can't root 7. But you can root 4, so it disappears like always, right? Everybody see the I, though? Right? Negative in a root puts an I right in front of the root, doesn't it? Last step, jump the 1/2 over. Answer is -1/2 plus or minus I √7/2. There it is.
Would you argue if you
Bless you.
Thank you.
Would they fault you if you just put the I in front of the square root 7/2, or no?
You mean like over here to the right?
Yeah.
Yeah, that's fine. Yeah, because I times root 7 times the order of multiply never matters.
Okay.
Either way is fine on that. Is that good? Are we good with that? Questions on that one?